Hey everyone, what is going on? It's time for another episode. I am the Savage Coder, and this is episode 17. In this episode, we're going to get into SQL Server, how to design tables, and how to get data out of those tables, and why we design things in certain ways. This is just the basics. I'm sure there's some great courses online. When it comes to learning all of SQL, that is a subject that could tie you up for your entire career. And there's plenty of DBAs out there that know way more than I do. But if you learn just the basics, you can use that knowledge to make complete applications that do what you need to do. This is going to be a longer episode because we have a lot to cover. So let's get to it. So in our last episode, I was not able to create a database diagram. I think I just needed a reboot. Everything worked after that. So let's take a look at the diagram. So here is our Savage Cell table layout that we created so far. It centers around the users table and the items table. And we have some foreign key lines going from table to table. We're going to go through what all of that means. And let's take a look at some of the basics in a little presentation so that we can come back here and all of this will make a whole lot more sense. All right, database schema basics. So we're going to take a look at how to build out a simple schema and why we make the decisions that we make and what all of these foreign key and primary key things mean in a real world scenario. So we're going to take a look at a simple table that we've created called users. In our users table, we have two columns, an ID and a name. So every name in our users table has its own ID. IDs are unique and cannot be repeated. What happens if we want to add a phone number to each of our users? Well, we could add a phone column and then put our phone number into that column. I'm using dummy data here to represent a phone number, but it could be in any format for any country. That works great. Now I can select Savage Coder from the database in the users table, and I will get back the ID of one, the name, and the phone. All good. But what happens if we want to add another phone? Maybe I wanted phone to be a home phone or a business phone, and now I want to add a mobile phone. Well, I could go in and modify the users table again, add another column called mobile, and just add more data. I hope you can see why this is a problem. Every time we want to add another piece of data to the user, we're adding another column. This could quickly get into hundreds of columns, and it makes maintaining this data very tough. The other problem is that our users table starts to lose its focus. It was just on users, but now it's starting to look like there's more metadata about the user than the actual user. We could start adding multiple addresses and other data that is tied to a user, but it doesn't necessarily belong in the actual users table. The other issue that we see here is that we kind of have what we refer to as repeating data. Now, the values aren't repeating, but we now have a phone number and then another phone number and then maybe another phone number, and it kind of muddies the idea of what a user is in the user table. So what if we split this out? What if we keep our ID and our name in one table, and then we move our phone numbers to another table? So now we have a users table that just has the original ID and name, and we have a phones table that so far has our phone and our mobile phone. So let's add an ID to our rows so that our phone data has an ID for each row that makes these things unique. So now, just like our users table, we have an ID and we have a phone and a mobile phone. But there's a problem here. How do I tie my phones back to my users? Sure, I have an ID 5 and an ID 6 that has more than one phone number associated with it. But if I just query data from the phones table at this point, I can't tell who those phone numbers belong to. I kind of need to look at the users table and grab the ID from one of those rows, and I need to put it in the phones table row in one of its own columns so that I can tie the user to the phone that belongs to that user. So what we've done here is we've added the user ID from the users table into the phones table, so that each row in the phone table now references the user's ID. So I know that phone number 444 and 333 belong to user ID 1, and user ID 1 is Savage Coder. Same with user ID 2 has these two phone numbers, and I can now join, if you will, user ID 2 to the user's ID number 2 row. And that's how I know that this row of data belongs to this person. But we can do better. So in our phones table, we actually have the same problem that we originally had in our users table, where every time I want to add a new kind of phone, I have to add another column to the phones table. And so I could end up with 5 phones, 6 phones. I don't know how many phones I'm ever going to need in the future. And I may only need a business phone today, but I may want to add mobile phones later. And I don't want it to become normal that every time I need a new piece of data, I need to change my database schema so that my tables can now hold another type of phone. So how do we deal with that? What we do is we create another table. This table is called phone types. It has only 2 columns, an ID and a name. Another name for this type of a table is a lookup table, because all we're really doing is looking up the name for an ID. It's kind of a mapping. So I can add data to my phone types that says ID 1 is my main phone, ID 2 is my mobile phone, and ID 3 is my office phone. And if I ever want to add another type of phone, maybe we have some old school business that still needs a fax, we could add a 4th row called fax. We could add any other kind of phone that we come up with in the future. We could have 4 could be a Google Voice phone. We don't know. So now what we want to do is we want to go back to our phones table. I've put these ellipses to represent the phone numbers that were in there. We still have phone and mobile phone in this table. I just didn't have room to put all 3 of these on the screen here. But imagine that this table still looks like the data that we had before. It's still there. So what we have to do is we have to classify each of these rows with the phone type. Well, just like we added a user ID from the users table, we can add a phone type ID to our phones table. So I'll add a 3rd column called phone type ID that's going to come from the phone types table ID. But we still have a problem. In my row here, I have 2 different phones. I have a phone and I have a mobile phone. But I have different phone types for mobile and for main, which we'll call our regular phone is the main number. How do I put a phone type for each of these phones? I could put 2 phone type IDs, 1 for each number. But that kind of gets us back into the same thing where I have to add a phone type ID and still have to add the number to this row for each number. It doesn't really get us out of the issue of having to change our schema for each of the rows. So what I want to do here is I want to split these 2 phone numbers and these 2 phone numbers into their own rows. So what would that look like? So now what I've done is I have separate IDs for our phone numbers. The first ID is the user ID, and I've color-coded these so that you can see which tables belong to which. So my user ID would be number 1, which is Savage Coder. So this phone number belongs to Savage Coder. The next column that I have is the phone type ID, which is also a 1, which says this is the main phone type. And then that phone becomes the phone number. So what this says is this is the phone number for Savage Coder, and it's of type main phone. Now I had 2 phone numbers, so I just add another row. It gets a unique ID in the phones table because Every row needs to have a unique identifier of some type so that we can identify this row. And then it also says that this belongs to user ID number 1, Savage Coder, but this phone type is a mobile. So the data for this phone is the mobile number. And then I did the same thing for user ID 2, which is Kathy. Kathy has a main number and Kathy has a mobile number, and those are the data for those. So now, if I ever want to add a new type of phone for Savage Coder, I add another row to this phone type table. I don't have to change the schema. I'm just adding data to the table. And then when I add the new number to the row, I'll just repeat the user that I need and the new phone type. I don't have to modify any of these tables to store any of this data today or going forward. And remember that the ID for user ID and the ID for phone type ID comes from those two tables, but the IDs themselves that represent the data are stored as the values in the phones table. So how do we access data? We access data with a SQL query language, or SQL. The operations that we query by are represented by CRUD operations. CRUD is an acronym that stands for create, read, update, or delete. So when we're creating new data, we use a SQL insert statement. When we want to read data from the database, we select that data out of the tables. When we want to change the data, we update with the update statement, and we delete with the delete statement. We are only going to focus today on the read, which is for selecting data out. So how would I get data out of my users table? Remember, my user table has an ID and a name. I can type select star from users, and the star would represent all of the columns that are in the users table. This is great for querying on the fly and ad hoc queries that you need, but it is highly recommended not to use star when you're creating stored procedures and other more complex queries, because it makes things less precise and opens things up to possible error. So we could name all of our columns instead of putting the star. The rest of the syntax is the same, but we then name the ID and the name column separated by comma for any of the columns that we want to get out of users. If we only wanted to get a list of names from users and we didn't care about the ID, we would just select a name from users, and it would leave the ID out of the results that we get back. What happens, though, if we want to grab data from our users and our phone table? Well, this next screen's a little busy, but I'm going to go through it step by step. So from the top, we have our users table. This one we've seen. It's just users with ID and name. Very simple. The phones table is the same from our example earlier, where we have the ID, the user ID, the phone type ID, and the actual phone number. This we've also seen before, and this should make sense. We know from our previous example that we can select from a table. If we select from users, then we're looking at just this user table. So I can select users.id, users.name. So the result of what I'm looking for in my select statement is I want the ID of the user, I want the name of the user, and then any phone numbers that they have in the phones table. So I know I have to join these two tables, and I know that I'm going to join them on this user ID. The user ID is a foreign key that points to the users table primary key. So all of the IDs in a table that make that row unique, in this case 1 and 2, in this table the 5 and the 6, are primary keys. They can't be repeated, and they make their data in their row unique. When I use a primary key in another table to identify that row having a relationship to the other table, that's called a foreign key. It is a primary key from another table. But in this table, it's foreign to this table. So when I'm dealing with more than one table, I have to tell it where I want the data to come from. If I just said select ID and not users.id, it wouldn't know if I was talking about the user's ID or the phone's ID. So I can denote that by using the table name or an alias, and we'll look at aliases in a second. But since my table is users, I can now say select users.id, comma users.name. And it knows to grab the user ID and the username from the users table. But what about the phones? Well, in order to join this data together, I have to use an inner join statement. There is also an outer join statement, but we're not going to cover that today. The inner join statement says, tell me what the two IDs are that you want me to join on, and tell me what that relationship needs to be, and I'll take care of the rest. So we give it the inner join syntax and then the name of the table. So we want to inner join phones, and we're going to join them on the user's ID, and we're going to make that equal to the phone's user ID. So this user ID in phones has to equal the user ID column in the users table. And if they're equal, then it will set up a relationship between these two rows. Now, in our case, there are two rows that have a user ID that is equal to the user's ID 1, so both of these rows are going to be selected out because the on clause equals is still true. The user ID still equals an ID in the users table. So we would get back from this query two rows. One, Savage Coder, and then because of the join, and we're selecting phones.phone here. So the only data that we're selecting out of this table is this phone number. So our result set would be user ID 1, Savage Coder, 444, 44444. Then the next row would match, because this ID matches this ID, it would again repeat ID 1, Savage Coder, 333, 3333. And the inner join will take care of repeating the initial table's data so that it can return a result that equals user's ID, user's name, phones.phone. So the one change we would make here is it's tedious to have to type users, phones, phones. So we can alias those. I would call the users table U and the phones table P. You can name them whatever you want, but that seems to make sense to me. So if we replace the table with the alias, it then looks like this. So anywhere we see this U dot, we're referring to the users table, and anywhere we see the P dot, we're referring to the alias for the phones table. Still the same query, just with aliases. So the question might come up, how would we select out just the mobile phone? Well, we know from looking back at our other data that we have a phone type table, and if we go back to our phone types, mobile is an ID 2. So we don't need to even use this in our query unless we need the text of mobile. If we did, we would join the phone types table into our query. Then we could select phone types.name as well. But really, I don't need the text this time. I just want only the 3333333, which is the phone type ID of 2, which is mobile. So let's go back to where we were. And let's add a where clause to our query to filter out the phone type ID of 1. So this is the same query up to this line here, but the last line is where P, which is our phones table, dot phone type ID is equal to 2. So now our row 5 here in the phones table is eliminated because its phone type ID does not equal 2. So we would now only get one row back, one Savage Coder, and the 333 phone number. Let's play with that. Back in our database diagram, we can now look at our users table. So our users table has a primary key of user ID, and it has all this other information that details a user. There is also an items table. The items that are listed on our site all belong to a specific user. So our primary key is the item ID, But the user ID is a foreign key that looks at the ID of the actual user. So if I join users to items, I can list the title and description of the item, and I can say it belongs to the user's first name because my ID ties these two tables together, and I can query on that. There is a one-to-many relationship between users and items. That's why the key here points to the users table, and the infinity symbol, meaning many in this case, points to the item side. So one user can have many items. One item can have many item tags, and a tag has many item tags. Well, how does that all work? So when we put an item up for sale and we assign it to a user, we can put tags on that item. We don't want to repeat all of the tags for all of the items. If we take a look at our tags table, you can see that I've added a bunch of different tags here. One item can fall under multiple tags. For instance, computer software or hardware can also be considered electronics, and it can also be considered computer science. So that one item could have 3 or more tags. So here, my item is tied to item tags, but my tags is just that list of tags we just saw. And the reason that we split them up into this middle table, and it's called a middle table because it really does sit between items and tags, and that's why it's called item tags, because one item can have many tags. So we would just repeat for each row, just like we did in our previous example in the presentation where one user can have multiple phone numbers. Here, one item can have multiple tags. Unlike a phone number that is specific to one user, a tag can be applied to many different items belonging to many different people. I can sell a guitar, you can sell drums. They both have the musical instrument tag, and they both belong to different users. So what I want to be able to do is say this item ID, in this case, guitar, belongs to me, and it has a tag ID of musical instrument. The next item ID is drums. It belongs to you, and it has a tag of musical instrument. So the item ID for drums goes in the item tags, and its tag is musical instrument. If that drum has another tag, you just add another row with the same item ID and the new tag ID. So we can add as many tags as we want per item ID by just putting it in a new row. Same way we did with the phone numbers and the users. It's just that in the phone numbers and users, you don't need a middle table because the phone number is not repeated across multiple users, unless your design requires that. If you have two people that need to share a phone, then you would use a middle table to solve that problem as well. We also have a middle table over here for user items. And what that means is when a user of our system is a buyer, they purchase the item. A user on our system can purchase many different items. So as soon as you have that scenario, you need a middle table to track all that. And each purchase would have a user ID, which is who purchased it, the item ID, what did they purchase, what did they actually pay for it, because in the items table there's an asking price, but maybe you negotiated down and bought it for less. And so we can track every item that is purchased in the user items table. So might not be really, really clear. This takes a while to kind of grasp. It's an abstract concept. But again, the more you work with it, the more comfortable you become. And I would say it's really common for new developers to ask for help with SQL when they first start out. I know I did. I added a bunch of data to our tables. So there is data in the items tags, item tags, user items, and users table. And I have exported the insert statements to add that data to the table. So I just wanted to share how I did that and how you can create your own database and use it for this project while you're following along. The first thing you'll do is create a database, and we did that in another video, but you just database, new database, and fill in your database name here, click OK. And that will create your new database. It won't have any tables, it won't have any diagrams or anything like that. So the first thing you need to do is you need to create the tables. I have generated a Schema Create, which I will upload in the API GitHub site. If you go to github.com/noblecause-code into the API project and into the API folder, there is now a data folder, and I will upload in there both of the scripts that I'm about to show you. So the first one is a Schema Create. It will go through and it will drop any constraints on those tables. And then it says if the table exists, then drop it completely. And once your database is all clean, it will create the database and add all the tables in with all of their key relationships. After you create your database called Savage Cell, you're going to open file or under file open, either way, and you're going to open this Schema Create. Once the Schema Create is open, make sure that you change this drop down from master to Savage Cell. You don't want to run this on your master database. This use Savage Cell here anyway will switch you over, but it's a good habit to always make sure you're on the right database before you run a script, because this use statement is not always there. And then just hit execute. Once you execute, if everything goes well, you should be able to right-click your database and do a refresh. Open up your tables, and you should now see the 5 tables that we created. After that, open up the data SQL. Make sure when you do, see how it went back to master here. Make sure you select Savage Cell and execute your inserts, and that will add the data into your tables. After that point, you should be able to right-click users and go to select top 1000 rows, and you should see your data in the bottom here. All right, so I'm going to assume that you have loaded all of your data and that everything worked. Let me know if there's any problems. And I'm going to click this new query button. I'm going to make sure I'm on Savage Cell, and I'm going to be able to write some queries. If I type select star from users and run that, you see the data comes back with all of my columns that are listed in the columns of the users table. The way I executed that, you can either click execute here, you can hit F5 on your keyboard, or you can use Control and the letter E for execute. And that one goes way back, so I just got used to doing that. So let's practice a little bit by looking at the diagram and see if we can look at our users and our items. So I'm going to just select star from items right underneath my users, and I'll get back 2 result sets. If I can make it run, there we go. So the first result set is the users query, and the second result set is the items query, and you can see the items has a user ID in it. So if I want to, and I can see that there are multiple items for user ID 1, multiple items for user ID 2, and user ID 3 doesn't even exist. And user ID 4 and 5, I made those unconfirmed or inactive by flipping these flags so that we can test that stuff later and actually have some data in there to represent an inactive user or a user that hasn't confirmed their email address yet. So how would I get back the user information? So let's start by selecting the columns that we want from our users table. So I want user ID, and let's grab the first name and the last name, and I'm getting these from this column on the left from the users table. Let's grab the email, and I'm going to go back to the front, and right after user ID, the second thing that I want to see is actually the username. So these can be in any order, and it will pull them out in the order that you specify here. So I'm going to say from users, let's just start with that. So I got my user ID, my username, my first name, last name, and email. That's exactly what I want. But then I want to see the item title, let's say. So I'm going to need to join my items table. And my items table has a user ID foreign key. So let's first alias my users table. And now I have to go back and put the alias before each of these so that in case the table I'm about to join on has any of these column names, which I don't believe it does anyway, but you always want to make sure you're grabbing the right data. So those columns will all come from my users table. And then I want to inner join or filter out anything from the items table that does not match on my user ID. So I'm going to match on the user's user ID is equal to the item's user ID. And let's alias items as well with I so that I don't have to type the table name all the time. And so if I just run this, if you highlight something, it will only run what's highlit. So we're not going to see these two come back in the results when I run this. We're still only selecting out the items from the users table, even though we're doing the join here. And if you notice, we're getting back the user ID for 1 and 2 because we haven't limited anything in our query. For each, this is going through each user in the users table, and it's just joining any items that they have. So if you notice, we're getting back a row for each item because there's only one user ID 1. But if you notice, we have 3 rows for user ID 1 and 2 rows for user ID 2. So let's take a look at what's driving that by grabbing the item's title. So at the end here, I want to do i.title to grab the title from the item alias. And I'm going to delete these so I don't have to keep highlighting. But now you can see that Savage has a guitar, Savage has a MacBook Pro for sale, and Savage has a Dan Marino football. Go Dolphins. And Colonel Carter has an ancient artifact and a DHD dialing device, parts for one anyway. Those are also for sale. So if I only want to see my items for sale and I know my item ID, if I don't, I can select star from users where username equals Savage Coder. And you have to use single quotes in SQL. So if I run that query, you can see my user ID is 1. So I can add a where clause where u.user ID equals 1. And now when I run this query, I'll only see items where the user ID is 1, and so the ID 2 rows are filtered out. So in my application, if I want to see just my items, this is the query I would use. Now I'd probably return more information about the items and less information about the user. Let's say I was filling out an item of my profile page where it just listed my items that I currently have for sale. So I could put items where u.user ID equals 1 and u.is active equals 1 and u.is, where is sold? Oh, the item is sold. Where the user ID is 1 and i.is active equals 1 and i.is sold equals 0. And we could even put an extra check of u.active equals 1. So what does that mean? Only show the user ID if they're active. If they're not active, don't even run this. and I only want to see item rows that are not sold but are still active. Maybe we can make an item inactive that's not yet sold. Maybe we're going to post it for sale tomorrow, so it's not live yet. That belonged to user ID 1. And so now we only get 2 items because something is filtering those out. Let's look at the data from items. And so you can see that there's only 2 items for user ID 1. That's these 3 rows. So only 2 of those are active and 1 of them is already sold. So if you want to see the items that are currently for sale, it is the unsold active items. So it would be item ID 2 and 3 only. And if you wanted to see the item ID, you could add i.item ID in there. And you see it is 2 and 3. If you wanted to see the tags for this, you can join in on the item tags. So I would inner join item tags. We'll call that IT for the alias. And this is going to join the i.item ID is equal to the it.item ID. Remember, we're joining this item tag, which has an item ID and a tag ID. So we have to bring in the tags table and we have to bring in the item table in order to get real information. Otherwise, all we're going to be able to select out of this table are IDs. And we'll do that first, just to as an example. Let's continue that. So that will join on the item ID. So if I now select out the IT dot, all I can really do is the tag ID for now. So you can see that now I'm creating something called a Cartesian join. And what that means is that I'm creating extra rows here. The user ID is listed multiple times, and the items now are listed multiple times because there are different tags. And in order to show the tag, I have to repeat the data to show the row to satisfy this select. And that's okay. That's kind of what we're looking for. So now what if I wanted to see the tag name instead of the tag ID? Well, in our item tag table, we don't have the tag name. The tag name is in the tags table, but I do tie item tags to tags by this tag ID, so I should be able to just interjoin the tags with the item tags. So if I go after this inner join, I can now bring in the tags table, and we'll call that T, and that will tie to the item tag dot tag ID would be equal to the tags table's tag ID. And we should get the exact same results back here, but now that I'm joined on the tags table, I can query out t.tagname and not only get the tag ID, but the actual name of the tag. And now it kind of makes sense why the MacBook Pro is listed multiple times for the same item ID, because it has all these tags. So if I just wanted to know what tags a specific item has, I can just grab, let me open up a new query. If I get rid of everything but tag ID and tag name, there's all the tags for that item. But what if I only wanted the tags for, let's say, the MacBook Pro has a bunch, right? So let's do item ID 3. So I'm going to add that to the where clause. And i.item ID is equal to 3. So that's how we could get a list of tags for an item. I think that's where we'll stop for today. So today we went over how to create a database schema, how the joins work, why we use joins and not just throw things into tables, a process called normalization. And we went through some queries and looked at how to do the joins in SQL Server tools. I think there's a lot to unpack there, so definitely practice that stuff. If it's not something you're really that interested in, you should probably just learn the basics of it, do as much as what I've done there, and Google the rest or ask for help. And people are generally pretty friendly online. You can find plenty of Facebook groups on coding that help answer questions. If you thought this was good stuff, please subscribe. That means a lot to me. And if you have any questions, please let me know. If not, practice, practice, practice. And next episode, we will go back to our C#. We'll start pulling some of this stuff together and adding the features to our application. So until then, thank you, and I'll see you online.